All right, everybody. I've noticed something in our most recent set of problems that there is a critical misunderstanding that I think a lot of you are laboring under. And I just want to address that by looking at one problem in particular. So here we have a problem in which we have a crane lifting an object of 2,500 kilograms a distance of 100 meters vertically. It takes 5 minutes to complete this task. Determine the power of the crane to the nearest 10 watts. All right, if that's the case, let's go ahead and use our problem solving techniques to go ahead and write out what we know. So first off, we know that the mass of the object is equal to 2,500 kilograms. Okay? We also know that the distance the object is being moved is 100 meters. And finally, we know that the time that that's going to happen in is 5 minutes. Okay, so those are all the variables that we've been given. Well, we need to go ahead and we need to start figuring out what the relationships are. Well, we know that we want to find power. So P is our objective. We don't know what P is. There were two formulas that were given that are related to P. The first one was this: P equals work divided by time. The second one was that P is equal to a force times a velocity. I'm going to tell you right off the bat, this is not a force times velocity problem, so we're just going to mark that out. That's not something that we need to consider. But our old friend work is definitely something that we need to think about. So, if that's the case, I don't see work over here, but I do know that work has its own formula. And I can find that work by doing work equals a force times a distance. F times d. Well, look at that. All of a sudden now I can utilize my d. I was using my t before in the power formula, but I didn't have work. So I stated what work was. I look over here and all of a sudden my d can now be used somewhere. But I still have a problem. I don't see in this list of all the things that we have F. And F is showing up in our work formula. I think the issue that a lot of you guys are having is that you're assuming something that's not true. This right here, I think a lot of you are assuming that mass is equal to force. And let me just tell you, M does not equal F, ever. But it is related to F. M is proportional to F. In fact, we know the relationship, the proportionality between M and F. And we know that this object, if it's being pulled up, what force is it acting against? Well, let's look at a free body diagram real quick. So if this object is being pulled upwards, the only force that we can really talk about that's counteracting that pull, what it's pulling against, is the force of gravity that's working on that object. Yes, its mass is important in determining that force, but that force is not its mass. So, to proceed in this problem, we need to now figure out what force is. Well, force, in this case, is equal to mass times the acceleration that the object is experiencing. Well, this object is experiencing acceleration, but it's a known acceleration. That acceleration is the acceleration due to gravity. We call that little g. And over to the side, if I really need to, I can restate what little g is. Little g is 9.8 meters per second squared. Okay? Now, the question is, do I have all the information to start breaking down all these different formulas, starting from the bottom and going back up to the top? Look, I've got mass, I've got g. That's going to give me F sub g, which is going to go right here. F sub g goes here. I've got distance over here. Then I'll get work. Work goes up here. I've got time over here. That's going to give me power. It looks like I've got everything I need. The only rub is something that I want to point out to you is this. 5 minutes. 5 minutes. Well, I don't, in my standard practice, use minutes for my units of time. What I want to instead do is I want to use my time in seconds, because that's how my formulas are set up. Look, this says seconds. It doesn't say minutes. For meters per second, it says meters per minute. So I need to convert that. Well, we should all know the conversion between minutes And seconds is just a factor of 60. So 5 times 60 should give us 300 seconds. So there we go. Now we have all of our different variables set up in a fashion that will help us to do what we need to do. Okay, so now comes the actual solving part. Okay, so let's solve all this crap down here. We'll start out with FG. Let's figure out what FG is. We're just going to go ahead and start slugging in our variables. So M and G together, so that's going to be 2,500 kilograms times G, which is 9.8 meters per second squared. That is going to be equal to, well, I don't know that off the top of my head, so I'm going to have to pull up my calculator. Let's see, that you can't see my calculator, unfortunately. That's going to be 2,500 times 9.8. That is going to give me 24,500. So let me put that here, 24,500. The units on force are newtons. Okay. Then I'm going to come down and start doing my work. My work is equal to the force of gravity, which we just stated was 24,500. Sorry, my handwriting is terrible. Times the distance. Well, the distance over here is 100 meters. There we go. 100 meters. Well, 100 times that is just going to add 2 zeros to the end, so this should be 2,450,000. The units on work are joules, so we're going to put joule here. And then finally, we're going to figure out what the power is. So power is going to be equal to this number divided by the time in seconds. So 2,450,000 divided by, oof, that was nice and bold, divided by 300 is going to give us our answer. And when we look at that, hold on, let me pull up my calculator. Times 100 divided by 300. Okay, that is 81,816666666. Repeating. So 8,166.6. The question, though, is asking us to take that number and round it to the nearest tens. Well, if I have a 6, that means that this is going to be 8,170 by the look of it, because 6 is going to round up. So 8,170 watts. Okay. If you use your problem-solving technique, you're going to very quickly see that you're missing variables. The point in doing these lists of variables over to the side is so you can critically look at the formulas that you have and decide to yourself, do I see those variables represented? When we first approached this problem, we wrote down all of our variables. We knew that we were going to have to find power, so I stated a power formula. When I looked at that power formula, I didn't see variables that I had over here for every single piece. I saw time, but it very quickly became apparent that I would need to find work in order to proceed. So I stated my work formula, and my work formula showed me that I had needed a force times a distance. Well, I saw that distance was over here, but force was not. So that meant I'm going to need to find some sort of force. Force then formula was stated, and we determined that the force that we were going to be talking about was the force of gravity acting on that object in a downward direction. Well, that force is defined as the mass times the acceleration due to gravity. At that point, we stated, something we already knew, that the force of gravity is mediated by the acceleration due to gravity, which is 9.8 meters per second. Then I had all the variables that I needed to solve for force first, then use the force in the work problem, then use the work in the power problem to get my final answer down here. So, y'all, what I'm trying to say is the error that you made, that a lot of you made, is this right here. You assumed that this subbed in right there, and that's just not true. You need to make sure that the variables you're writing down to the side represent what you think they represent. This is not a force. This is a mass. So especially in those problems where you have this sort of situation where you got an object that's being picked up somehow or pushed up a ramp or pulled by a pulley, you are going to be working with the object's weight, the force of gravity pulling down on that object. And so the force that you need to plug into the work problem, by and large, is going to be the force of gravity acting on that object, its weight, which is to say F sub g, or W, little w for weight, equals mass times gravity. I hope that's a little bit more clarifying for you. That certainly gives you a leg up on at least one question. I know in one of the previous exams, a lot was asked on you in terms of determining the weight of objects. So just get into the habit of determining the weight of the object if you see that it's being picked up and you've been given a mass. That's my best suggestion for you. Even if you don't know if you're going to use that weight, it's good to have it just in your back pocket in your list of little things that you know about the problem over here. Okay? All right, I hope that helps you all. I don't know where my mass is to stop this recording.